Thanks for joining. My name is Eric Gabby. I'm an enthusiast for all things nautical and aerospace. I served for 22 years in the U.S. Submarine Force and have been supporting it for the last 14 years since retiring. I've been an aviation enthusiast since I was 10, so join me while I pursue my passions through first-person experiences in history, exploring aircraft, ships, and historic sites that have changed the world, and for some that are really off the beaten path. Today we're in Seattle at the Museum of Flight to look at the Concorde Golf Bravo Oscar Alpha Golf, or Alpha Golf for short. This aircraft is on display at the Museum of Flight and has been since the Concordes were taken out of service. It is one of my favorite aircraft and has been since I was a young one. This just shows how the aircraft is situated at the museum. Now let's climb up the stairs and take a look inside. You'll see the Air Force One 747 and 727 in the background there. Just a quick pan around so you get situational awareness. Now as we step into the main access door, it's actually a very small aircraft on the inside. I am 6'1" and have to duck my head to come in. And as you look on your left, you'll see the cockpit. It is run by a cabin crew or cockpit crew of 3, pilot, co-pilot, and the flight engineer. Flight engineer handles all things related to ship systems, the fuel, electrical systems, things of that nature. We'll discuss some of the quirky little things later on in the video. But pilot, co-pilot, and they have the controls for all 4 engines, as well as you can see the electronics and everything there in the passageway sides that line it. Now we're going to take a turn around here in just a moment to look at some of the creature comforts on board. It's a galley here as you first enter, as well as a lavatory, general catering, coffee machines or coffee makers, things that storage ovens for in-flight catering. Now we're making our way aft here, more catering and lavatory there on the left. I'll talk to you a little bit about it on the outside of the aircraft in the external tour. Now working our way aft again, continuing with the forward galley, just more storage for in-flight catering. Now starting to head our way to the aft, and you'll see that the seating is in a 2x2, and that the seats are the rival of any of the commuter airlines that you may have flown on before. They are honestly not very large, but they were selling speed on this aircraft, not physical comfort. Being able to cross the Atlantic in just right at 3 hours was the luxury in and of itself, instead of having to do it in 7 or 8 hours in a subsonic, 747 DC-2, those kind of. Now, as we make our way continuing on aft here, you'll see there's some fun facts here. This one on here shows that as the aircraft heats up, that it actually stretches between 6 to 10 inches because of the heating. And on the other side has to do with one of her sister ships, Alpha Delta. It set the transatlantic record for 2 hours, 52 minutes, and 59 seconds. And continuing aft, the lavatories, one port, one starboard, gives you an idea just of the creature comforts, reciprocal on the other side. And they have the aft half of the cabin in its original configuration. Here the plexiglass makes it a little difficult to see through, but you can see how the seats were without having the large plastic covers over them, to give you an idea what the creature comforts actually were like. Now we're going to step outside to the midships door on the port side to take a look at the wing. Concorde's wing is called an ogivale, or double delta wing. You'll see here as I pan to the left that the near portion is a shallower angle and the far portion is a steeper angle. It makes for better performance at supersonic speeds, and it was used on several other aircraft, including the Russian version, the Tu-144 or Concorde ski. Then you can just see the size of the aircraft wing compared to the 707 that you see right in the background. Just taking a look here at the nose of the aircraft. You'll see obviously the pointy end is that way. This is the secondary door on the front of the aircraft, so the starboard side. Obviously you can see here for the servicing of the lavatory. One interesting thing that you'll note here is this little mast that sticks out. This is a heated drain mast, and you'll see I'll point them out a little bit further along later. It has to do with the drain of fresh water from the galley and from the lavatory. So I'll put in a nice little diagram of how they work into the video here right along with it. And we'll go up to the forward landing gear. So forward landing gear, forward door, those will open up and allow this gear to rotate up into that space. And you'll see that it is a dual set, actually pretty good sized tires. And I'll point out here that this is the hydraulic cylinder that allows it to steer. This has obviously a left right hand side, and that allows it to rotate on this joint to steer the tires. And there goes the aircraft. Walk along a little bit more. This is access to the forward baggage compartment. So you got to put bags somewhere, and then on here that's cargo hold. And continuing along, the underside of the wing has plenty of accesses here. This is essentially a flying fuel tank. You'll notice the ovals here. These are lower accesses to the fuel tanks. And in front of us, you'll have tanks 8, 9, and 10. These are the forward trim tanks that allow to move ballast, i.e. fuel, from forward and aft on the aircraft due to change in flight dynamics once she goes supersonic. We come along here to the main gear. You'll see the inboard doors for the main landing gear. Those will rotate down, one from port, one from starboard, and they'll effectively meet, allowing this wheel to rotate 90 degrees up to inside the wheel well where you see the brown parts there. Concorde is unique in that the wheels, whenever they are fully extended, you see how they have the limiting arms here. When it is fully extended, it cannot house the wheels. It actually has to retract back into this condition here. Normally whenever it lands, those are fully extended, and it allows it a cushion to absorb impact from landing, but it has to pull itself back up into this position so that the wheels will physically fit into the wheel well. Just give you another look here. One thing to note about the forward nose gear, there are no brakes on it, but here on the aft, the main gear, this is the braking mechanism inside. They're generally made out of carbon fiber to allow them to take a severe punishing amount of heat on wing. We have the inlet nacelles to engines 3 and 4. These are on the right-hand side. These have variable geometry. On the part that says danger, that part will actually rotate, can be hydraulically powered down, and there is a second flap on the inside behind it that allows it to change the geometry of the air coming in to eliminate the shock wave once they're supersonic, to allow the air at subsonic speed to enter the engine to keep it from encountering issues or an unstart. Now Now, part of the engine air bleed system are these two massive dump doors here. These can rotate down. You can see the hinge point on the forward part. They allow the engine air to be controlled in the volume of it that enters the engine. That it is not always optimal just getting as much air physically into it as you can. So these can allow a dump path for air entering before it continues on to the forward part of the engine. And also these two little doors here are part of that air ingestion system that allow them to bring in extra air, especially at low speeds for takeoff and landing. So these all work in concert. They are run by a computer. The Concorde was one of the first aircraft to ever have, essentially fly-by-wire, or in this case, engine control by. So this is the Rolls-Royce Olympus 593. It's the same engine that got its start on the Avro Vulcan, which is a Cold War one of the V bombers. It's a very large delta wing aircraft. Has an amazing history and story behind it, and it was used in the bombings on the Falkland Islands War, and it was the longest sorties of any kind of its type well into whenever the U.S. got into the Middle East. So you'll see the forward part of the engine would be here. That's the low pressure end of it, but as you get further aft, you'll see that the color changes. This is most likely, I believe it's a titanium. So it allows it to take heat, and it will, obviously it's not painted because the paint would not do very well with a very high heat environment. And I'll rotate you around here to the back end. So this is tail end. These are what are called bucket scoops, and these allow for 3 different configurations. What you see it in right now is the subsonic flight, so there's a path that air can take to come in from around it, mixed with air coming through the engine. So that's the optimal performance for subsonic flight. What they will do is you'll see there's hydraulic actuator there. There's 4 of them on each bucket. They're hinged, and each one has a left and a right. But what that does is for landing, they can fully close these where they form like a clamshell, and it can take thrust and go it from a pushing it forward direction to putting thrust towards the forward and actually helping to decelerate the aircraft. So thrust reverse is the mechanical bucket. And then the third position would be for supersonic flight. It will rotate down where it meets up flush with this portion. And that is the optimal configuration for supersonic flight. So pretty nifty little system. It's quite massive in its scale. These engines are huge. So one thing to do about this is everybody talks about that this had afterburner or reheat. Yes, it does, and the afterburner was only ever used for two situations. It would be used for takeoff, and the extra thrust was needed because this aircraft had to get going at incredible speed to get going, so it needed the extra. But also, it was used to accelerate from Mach 0.7. They would kick in the afterburners, and they would accelerate to, through, and then beyond the speed of sound, getting up to Mach 1.7. At Mach 1.7, the afterburners would be shut off, and the engines would continue to run at 100% power, and that was enough thrust to continue the acceleration to Mach 2 and just a little bit beyond. So it's some people assume that they ran the afterburners the entire flight. There's just no way you could physically carry that much fuel, so it would end up the engines run at 100% power. Just kind of give you the scale and walk around a bit here. So very, very amazing engine, and just impressive to see in person. now one of the quirky things I'm going to share with you is I'm going to zoom in here. This door that you see with the pin engaged in it, that contains the ram air turbine, or the RAT. The RAT is the emergency power source should all four of the engines lose power and shut down at the same time. What happens is there is a small two-bladed propeller that rotates down 90 degrees, and it is mechanically linked up to just inside of the fuselage there to two hydraulic pumps. And what it does is it provides hydraulic power to both the green and the yellow hydraulic system. The aircraft has three redundant hydraulic systems, yellow, blue, and green, but this ties into yellow and green. But the way it differs from other ram air turbines is that it is hydraulic power only. And what the hydraulic does is there is, off of the green hydraulic network, a small hydraulic to electrical generator that this provides hydraulic power to keep the aircraft running, and then the small generator for minimum essential power runs hydraulically off of hydraulic fluid from the ram air turbine, which is driving a gearbox that feeds the two pumps that I talked about. It's a pretty interesting little thing. I will put in a graphic here that shows what it looks like. And what's quirky too is that once it deploys, it cannot be reset in the air. You must do it on the ground. So once it deploys, you are landing somewhere reasonably quick. Zoom back out here. So but that is on the port side next to engine number 2. So where you see the air conditioning hooked up to is the same ports that air conditioning would be hooked up to ground service to provide air to cool off the aircraft during routine weather, be it heated or cool, depending on where you're at in the world. One thing too that is unique about Concorde is that it does not have an auxiliary power unit. So the only power that it can get once all four of the engines shut down are from the ram air turbines, which I discussed here just a few minutes ago. That's the bay doors that open up for it to deploy from. Just getting some more footage here of the main landing gear on the port side, main gear 3. I'm going to walk around back towards the back part of the aircraft here. So control surfaces, it is a large tailless delta wing that uses these flaperons. They have both the function of flaps as well as ailerons. So you see that they're buried all the way into, even between the engines and the fuselage. You can see the amount of travel that they'll go through, the plus and minus of that. And like I showed you earlier, this is a heated drain mask from the aft lavatory. So whenever you use the sink, that's where it comes out. Not to be confused with they collect all of the from the toilets that gets collected in a holding tank. So now, unique too about this is in the area just underneath where you see the Bravo Oscar Alpha Golf is a very large fuel tank. That is fuel tank number 11. What number 11 does is allows them to take fuel from the forward 3 tanks, 8, 9, and 10, and pump it back here to change how the aircraft is trimmed. When the aircraft goes supersonic, the center of lift and the center of gravity on the aircraft change and shift 6 feet to right at 2 meters aft. And what that does is it causes the aircraft to be nose heavy. So you can use control surfaces to make up for that, but that causes excess drag and causes loss of speed and also efficiency. Or what you can do is you can take ballast and move fuel from the very forward tanks to the very aft tanks to make it tail heavy or nose light to account for it, so to even it out to trim the aircraft. Now, they do have a tail wheel. This is to prevent tail dragging or tail strikes. This aircraft comes in at a very high angle of attack on landing and on takeoff. So this will prevent physical damage to the aircraft should that scenario happen. Okay, this is Concorde engineering prototype number 1 in Bourget, France, just outside of Paris. And I am climbing up through the stern. So this was a prototype, was not in commercial service. Let's kind of pan around and let you see the construction inside. Pressure bulkhead here. And I'm 6 feet and I can actually put my head up against the ceiling if I barely step up on my tippy toes. You can see it was rivaled, at least in size-wise, of your average commuter, turbopropped kind of airline. So since it was engineering development model, we have extra equipment here in this section. You'll see whenever I go into one of the production ones here in just a minute that all of this equipment and everything where I'm standing is not here. It's seats and lavatories and galleys and everything. So this will take you into the cockpit. So now we're going to step from a prototype to a production aircraft that flew for Air France. Just stepping in here. And you'll immediately notice differences in the flight deck. And coming into the fuselage, the seating,
3 hours and 25 minutes.
Not the most comfortable. Tiny windows.
To be fine, and I wish you a very pleasant flight.
This is what the aft cabin looked like. So this is obviously representative as flown. So you can see 2x2 configuration that not all that comfortable to see, but it was selling speed, so you can cross the Atlantic in 3 hours. Hey, life is good. And so this is, obviously prototype number 1. So, how many of the 18 remaining Concordes around the world do you think that I have seen? The answer may surprise you. A total of 8 of the 18 remaining. 2 at the French National Aviation Museum in Bourget, France. 1 at Charles de Gaulle Airport just outside of Paris. 1 at London Heathrow Airport, static display. The National Air and Space Museum, Washington, D.C. Imperial War Museum, Duxford, England. Intrepid Sea, Air, and Space Museum, New York City. And Museum of Flight, Seattle, Washington.